Now?
Yeah, now it's good. Thank you.
Yeah.
Sure. So what do you think this code is doing? You can call a friend if you don't know. Pick anyone from the class. Call a friend or call a co-student. I will give you the liberty to pick anyone to help me understand what this code is doing. Who do you want to pick? Karthikeyan, you have been picked. Go ahead, Karthikeyan. What? Hmm. Mm-hmm. Okay, so what do you think this code is doing then among the two or between the two that you mentioned? You can see the code, no? This section. Explain line by line. 1, 2, 3, 4, 5, 6. What do you think this is doing? Hmm. 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 So what does it mean 0 and 1? Nope. You tried your bit. You can pick one more person from the class. Pick anyone. They will not feel bad. They will feel very happy. Huh? Who do you? Arpan, you have been picked.
So here we are doing normalization.
Huh.
Means here, what is normalization? Why we need normalization is if we are having multiple features in our data set and not update features, and they have different. Each feature is having different range of values. So range of values means some features can have a very big value. For example, salary. Some features can have a very small value for age. So if we create any regression model of the with using that without with the same values, so in that case, model can be influenced much by the bigger values. So in that case, to overcome that, we need to normalize the all the values within a range so that everyone will be become into the same range. So all values or all features will be treated same ways.
Good. Now explain the code.
Now this is normalization.
Hmm.
Because here what we are doing, we are creating min-max scalar object and min-max scalar feature range. It will be whatever features like T class, gender, age, sibling, whatever features we are having, all the features values it will be changing to between 0 to 1. So all the range will be range here is 0 to 1. So P class, gender, age, sibling, whatever value we can see it is values are between 0 to 1, 0 to 1 and it is normalized. So now all the features should be treated similarly. And next line, what we have fit transform means we are fitting it. That we are changing that. We are applying that change. Now we are Titanic transform is the values. It is and it is maybe it is all the values after transforming. Now I'm using that. I'm creating one data frame where we are putting only X column. X like in X columns we are giving the X values. So transform values we are giving. So if we give like scale Titanic data frame dot eight, we can see the data frames which are having all the features for X, like particular columns we are having with the transformed values or normalized values.
Okay, good. Thank you. So three of you solved it together, right? So over here we are importing the min-max scalar which is for normalizing the data, right? So I think everybody is aware of the concept of the normalization, which is I want to make all my features on the same scale. So nobody should have an undue advantage because of higher values or lower values or fractional values and all that. So everybody will be on the same level playing field, right? Here, we are creating that instance, which is the min-max scalar. And we are saying, I want all my features to be ranging between 0 and 1, right? So all the features, the minimum will become 0, the maximum will become 1. So for example, if age was 80 as the maximum and 0.76 was as a minimum, after the scaling, it will become 0 and this will become 1. If fair was 525 as the maximum, and I'm just making up something. So 25 was the minimum, right? So this will become 0 and this will become 1. Is this clear? So all the variables will become 0 to 1, regardless of the scale that they're on. And over here, since we have created this instance, now we are doing similar to what we've been doing in the modeling, which is the fitting and transforming. So it's two things combined together. This object, this method is two things combined together: fit and transform. Fit and transform meaning whatever you have been trained as an instance over here, fit that instance on this data and also transform it. So transform meaning it will no longer be the original axis, it will be the 0 to 1. Clear? And then all we are doing over here is some cosmetic things, which is, taking this array over here, converting that into a data frame, and then appending the column names, and then we are doing a head and describe, right? Clear? So, hmm, hmm, hmm. In what? On the entire X array, correct. Hmm. Hmm. Mm,
If your test train data may not have, we have a different minimum, say
Hmm.
like that.
hmm.
And the test data has an actual minimum.
Yes.
Then it already knows that there is some other data which has been.
I see what you're trying to say. So you're saying like when I've scaled my entire X and then we are splitting. So the train and test may have some differences between them, which may influence the model performance, right? But because it's 0 to 1, all of them, right? So even if like, you don't have a like absolute 0 as the minimum, because we've done the random splitting, you will assume that you will be like closer to each other. Ah, that's right. It doesn't matter so much. Yeah, but it doesn't matter so much because you're taking a random sample from that X array. So if not 25, it will have 26. It has learned that behavior, right? So it doesn't have to be the exact same data. And that's why it's important not to have exactly the same data as in the train versus the test, because you want to have a generalization capability of the model. So if the model does a beautiful job on your training data and it falls apart on your test data, it's not generalizing well. So that model cannot be relied on. So it's okay not to have identical looking data. Hmm. Yeah, that's fine. No problem.
On this feature scaling, right? This
Mm.
term was the category. So categorical category should be doing the feature scaling because they are 0 and 1.
That will not be influenced too much because there's 0, 1 anyways. So they will continue to be the 0 and 1s. Mm. Mm. Yeah. So for example, you can take a look at the gender, right? So nothing changed in the gender. It continues to be 0 and 1 because either you had 0 or you had a 1. When you're doing the scaling, then it continues to be 0 and 1. But let's say if you have three values, which were 0, 1, and 2, now 2 will become 1 and 1 will become 0.5 and 0 will continue to be 0 like that. So it doesn't really matter so much. I mean, but if you don't want the categorical to be scaled, you can keep them away and then bring them back in, right? So those things can be done as well. Are we good so far? Notebook. I can share, but you're also supposed to be submitting that today, the assignment. Sure. Yeah. So we have like scaling them. So you can see pretty much all the variables are 0 to 1. No randomness there. And you can also try the standard scaler. So standard scaler, Karthikeyan, you were saying that it will be doing the scaling on what to what? Standard scaler? Were you reading from somewhere? Huh. You were correct that time. Now you're not correct. Tell me, what does the standard scaler do? Yeah, so instead of doing the scaling between 0 to 1, as we've done in the min-max, this will do a -3 to +3 standard scaler, right? So most of the values should be there between -3 to +3 if it is a normal distribution, right? So going back to your statistics class, which is ±1 standard deviation to 3 and 99% of the like observation will be there. So I'm not going there, but you can assume that you can do either one of them. And if you try standard scaler versus a min-max scaler, your output may look different, right? So these are like, that's why the AI is art and science. It's not 100% science. It is also art, right? So your model could be better from my model because of some of the things that you've done differently in the whole activity, right? Is it clear? Okay. No, either one of them is fine. As long as you're following the entire process, yeah? Yeah, why not? No problem. The underlying essence of the data continues. So you basically, instead of measuring your distance in kilometers, you're measuring your distance in meters, right? It's basically the same thing. Or instead of measuring it in meters, you're measuring in feet, right? So min-max. Because we want all the variables to be on the same, exact same axis. Why not? Because you're saying like regression, I want to have them on the same scale so that they have equal advantage or disadvantage, right? If they're on the same scale, the coefficient will be apple to apple. If I have a higher coefficient in one variable, because it's measuring from 0 to 1, variable 2 is also being measured from 0 to 1, the coefficients are really directly interpretable in terms of, what the higher or lower variables are. If you do anything without the 0 to 1, let's say you do -3 to +3, but because one distribution was shifted towards the right, so it's not going to be -3 to +3. It could be +10 also, right? So that's where I think the 0 to 1 also is a very, very robust way of doing it, because there is no guarantee that just because you've done the standard scaling, all your values will be between -3 to +3. They can be higher or lower depending on the skew in your data. Okay. Try both. Try both and see what works better for you. And this is one thing that I can tell you as a general recommendation, that anytime you have to really build a good model, try different things. Don't think about like, this is the fixed formula that I'm going to try. So try different things. So instead of using the IQR for the outliers, try the flooring and capping. Instead of trying the flooring and capping, try the IQR. See which data or which pre-processing, which data cleaning gives you a better result, right? Feature engineering is very, very important. Like all the data pre-processing, feature engineering, and then you will move on with that. Yeah. So this step is clear, which is the breaking of the test and train. Something similar we have done in the linear regression. I'm doing 80-20 split. and random state is 999. So that will basically have a certain section of the train and test data broken out in the sample, right? So your train and test sample data may look different from mine. So don't be surprised. I'm looking at then the creation of the instance, logistic regression instance. All good. And then we are fitting the model, train and train. Then we are doing the prediction. So you can see once I do the prediction, then we get this 0 1s, right? So the predicted is nothing but your classes have been predicted. All good so far with me, everyone? Anything which is not clear? So once you get the zeros and ones, then you're gonna do your classification report, right? So matrix.classification report, you're gonna pass on your actual and your predicted values, right? So your actual and predicted values, and then this will give you your classification report. So let's spend some time talking about this. So the recall for one is 66%, and the precision for one is 74%. Now, if you compare with the zero, you can see like, for zero, it's slightly better for both of them, right? And then you have these numbers as well. So let's do a random number or random name generator and see if people can help me understand each of these up to an extent. Karthik. Yeah, Karthik. Just a second, I'll come back to it. So Karthik, for you, easy one. What are these? You want to call a friend? Pick anybody. Or shall I do a random number? Huh? Random number? Okay. Let's see. Karthikeyan, you're again selected. Huh? What are these numbers in the classification report? You want to return the favor to Abu Bakr? Fast. You should not be taking this much time. Either you know or ask somebody else to help you. Fast, ask somebody. Arpan is not there. Ask somebody. Anupam says, pick me. That's right. See, Anupam knew it. So, and I knew he knows because he was coming. Okay, pick me, pick me. So that is correct. So this is the number of observations we have in the 0 and number of observations we have in the 1 for this. Where are we doing the prediction? We are doing on the test data, right? In the test data, this is the actual values. In the test data, these are the predicted values. And these are the number of observations we have for the 0 and 1 in the test data. So there are 97 zeros and 59 ones. Is this clear, Karthik? All good? Okay, we'll pick somebody else for doing the interpretation of the next. And sorry, one more thing before I go on. And this is nothing but the overall number, right? So if you add these two, this is this. So I hope this part is clear, 100%. Is there any confusion from anyone? Okay. That's okay. That depends on your split also. Tarun is here or online?
Yes.
Tarun, you want to come online and help me with some of the things?
Yes, sir. I can try.
So the question for you, Tarun, is the F score. What is the F score?
Mm,
Is Tarun talking?
No idea. I was thinking, sir. No idea.
No idea. Then pick anybody, Tarun. Okay, you don't have the visibility in the classroom. Okay, so I'll pick somebody.
Thank you. Thank you, sir.
Rahul. You want to try? No idea. Pick somebody from the class. Let's see who's looking more confident. Sachin, go ahead.
Recall through which provides single scroll of balance information.
Hmm.
Basically, who can I explain the other? So precision is, the accuracy of positive findings that are more or less done. And recall is,
No, just to explain the F score. I think this is what you're trying to say, right? Which is the harmonic mean, like arithmetic mean. Yes, yeah. So if you take a harmonic mean of this number, which is this number, and this number, you will get this number. Similarly, if you take a harmonic mean of this, you'll get this number. Is this clear? So why do we have F score? You're not done yet. Why do we have F score, Sachin?
because precision, only identifies how many times the accuracy of the positive findings are more or less found out. And recall is the ability of the model. So that's what we're trying to find out. And if one finds out the mean of both of these. So that's why we have F1 scores.
Yeah. So if you cannot decide whether precision is more important for you or recall is more important for you, then you have F1 score that you can say, I don't really cannot choose between the precision and recall. I want to give them the equal importance. And that's why I have the F1 score. So I'm hoping this is clear, everyone. F1 score, what exactly it is? Hmm.
How do you treat the model?
It depends on your business context. Remember last time we were talking about like if there is a false positive cost, there is a false negative cost, right? That will help you figure out what is more important for you, right? I mean, do you want to optimize precision or do you want to optimize recall? And let's say the both costs are equal for you, then you say, okay, I will just go with the FN score because it's a good striking balance between the precision and recall, right? Accuracy of the model, that's from the confusion matrix. See, remember, accuracy for a layperson is like the mother of all metric. They'll say it's very accurate model for a layperson, right? For us, accuracy doesn't mean much. What means much more than accuracy are these numbers: precision, recall, F score, all of those things, right? So I'll come to the accuracy part also when we look into the confusion matrix. So accuracy for your model is 78%. But this is not good enough, right? So you need to understand all the other metrics associated with this. So that's where we are coming in from. Okay, so I think we've covered F score, support, and these. Is this clear, everyone? All good? I will give 2 extra bonus points to somebody who can explain the difference between the macro and the weighted average. So this is the macro and the weighted average of nothing but your F score, what we're looking at over here. So for 2 extra points, if you're like ever needing those points in your grading, will be yours. If you can tell me the difference between the macro and the weighted average. Not right? Okay, you raise your hand first. Yeah, go ahead. Pavan, out of the, you want to try, Poonam? You guys decide. Hmm.
Weighted average of F1 score of 1.
Okay. Great. Yeah. So that is the correct answer. But why do we need the weighted average then? Yeah, that's right. That's right. So the macro average, so you get 2 bonus points. I'll keep in mind. If anytime you're in doubt, just remind me that you promised me that, right? And Pawan, you also get 2 points if you're saying the same thing. Same thing. So the macro average is nothing but the arithmetic average. So if you take 0.83 plus 0.70 divide by 2, can you confirm whether you get this number? Anybody who can do the fast math? Correct? Okay. And then what is the weighted average? Weighted average says 0.83 times 97 plus 0.7 times 59 divided by 156. So I'm weighing this number against the number of observations I have. I'm weighing this number against the number of observations I have. And then that will give me the weighted average. I'll take a pause and see if people you are clear or anybody has any doubts. What is more simple to you, Python or machine learning so far? Because you just started. What is more intuitive, Python or machine learning? You've done the Python and other things earlier on. We're doing the machine learning and some of the concepts now. What is simpler for you to grasp? Machine learning, right? Because it's very intuitive, right? So it's not really like, you don't have to remember the syntax and all of those things. It's very intuitive, right? And why we're doing that also is very, very intuitive, right? So now let me just go and see whether this number makes sense for you or not, right? So we are looking at 0.83 was the F score for 0, 0.7 was the F score for this. So is this making sense or not, the weighted average? And why does it make sense? Again, intuition. Why does it make sense? That weighted average, that in this case, weighted average is greater than the arithmetic average. Why does it make sense? Because I'm giving more emphasis on this. It has a higher number of observations, right? So the bigger number is coming in because 97 observations are coming in for this higher number and only 59 numbers are coming in for this lower number. So that's why the weighted average is more than this, right? So versus the arithmetic average, which is nothing but your 0.83 plus 0.7 divided by 2. Okay. Now let's do the mother of all precision and recall interpretation. So till now we have covered this. Anybody's confused, don't be shy to ask me. So we have covered this, so which is nothing but the number of observations. F score is nothing but the harmonic mean of these. And then these are nothing but the simple average or the weighted average to really do this, right? So now we're coming to this part. Everywhere. I'll give you a puzzle problem, which I keep on asking in the interview, and only one person can answer me, right? So shall we do a puzzle? Huh? Shall we do the puzzle? Okay. So let's say I have a portfolio. This is a very favorite interview question for me. And I have product A and I have product B. And I'm looking at the profitability of my product year over year, right? So let's say I'm looking at 2025 and 2024. In 2024, the profitability on my product was 40%. And in 2025, it has gone up to 42%. Like per product I'm selling in product A, I'm making more profit, right? Product B, the number was 70% and it has gone up to 75%. And I only have two products, product A and product B in my portfolio, no other product, right? So you can see the profit margin for product A has gone higher and profit margin for product B also has gone higher. But my MIS, which is the Management Information System report or like a dashboard, suggests that my overall portfolio overall portfolio has become less profitable in the same time period? Is it possible mathematically? Don't go into the expense, don't go into the marketing, discount, all of that. Just a simple math problem. How? Hmm? It's all here. It's all here. It's all here. Exactly. So the product mix has changed. So let's say in 2024, you were selling 70% of this and 30% of this, right? Versus in 2025, this became, the product A became your 30%. Sorry, I'm saying it wrong. So let's do this. So in 2025, the product B was, let's begin with this 2024 and 2025, right? The product mix A and B. So in 2024, B, which is more profitable, was 70% of my product portfolio, and this was 30%. In 2025, the mix changed towards product A. So now this became 80%, let's say 80% and 20%, right? So because of the weighted average, so I have to take the 80% of the profitability on this product versus 20% of the profitability from the product A versus 75% in the earlier year. So even though both products became more profitable, but your product skew changed towards a less profitable product, right? And that's where your profitability has come down. Pure mathematics, no other business logic, nothing else. It's just a simple product mix thing, right? So that's where the weighted average really comes in. It's super important. A lot of time people get really confused. Like, I mean, both are becoming more profitable, then why are you claiming that my portfolio has come down? The underlying thing is that the mix has changed. So in what? That's right. That's right. Yeah. Product mix. Yeah. That's right. That's right. So that's why this is important, weighted average as well, along with the other thing. Now let's pick the person for the precision and recall. I'm sure everybody is reading during this time, but that may not help you too much. Toya, you're the lucky one. Help me understand these two values, Toya. Recall for 0 and recall for 1. Plain English, like Arpan was explaining in the morning. Don't say true, positive, true, negative, false, positive, false, negative. Just plain English. How would you explain this? Mm-hmm. Okay. You agree, disagree? No comments. No comments? Pick somebody else then from the class who can help me. Huh?
Point six eight are the real positives that was identified by the model.
Hmm.
And 0.86 was the uh, uh, maybe real false positives that was identified.
Mm-hmm. So from the, and I think you're saying the same thing as Alpon. So from the overall survivors, who actually survived, my model is able to detect only 66% of them. From the people who really survived the crash, 66% of those were correctly identified by the model, right? If I don't have the model, what is going to be the odds? 50-50, right? So if I don't use a model, I can randomly say there is a 50% odds, like if I pick a person, whether they were, because it's a binary class only, right? 0, 1. So my model, if I don't use the model, I would have been getting this rate as a 50% versus using the model, I'm getting this rate as a 66%. So this number is nothing but your lift in the model, how much lift you're getting in your recall, which is not a whole lot. right? So this is not really a great model because you're able to detect only 66% of the survivals. The remaining 34% of the people, your model says, I'm not able to detect. So let's say you were using this model real time basis, right? Who is most likely to survive? And they're out there in the water and you have to send a boat in that direction immediately, right? Imagine it's all happening real time right now. So then 34% of the people are still in the water waiting for a boat and the boat never came because your model was not able to tell these are the people who have a high likelihood of surviving, right? So that means you basically miss out on those people, right? What is this? 86%. That means basically people who were non-survival, 86% of those were correctly detected by the model, correct? Let's do the last one. And that's why I said in the precision recall, we'll keep on doing this until it's drilled down in your mind forever. Yeah. Either you can fine tune the same model, make it better, or try a different technique. And all the things we're going to talk about in terms of the hyperparameter optimization will come in, right? Karthik, you've been chosen again. Acha, the other Karthik, sorry. Yeah, precision. 81%, 74%. Both you need to explain. So I was given the idea that I should do a Viva in the final exam. Now looking at the trend, I'm not very hopeful. So I'm doing the Viva right now so that you get all of you get good marks in your final exam. Because if I start doing the Viva in the final exam, then God help me. So this is your Viva right now. And I will remember people who are giving good answers and not so good answers and paying attention, not paying attention. Anyone?
Actually true.
Hmm.
So that is the score my model is planning. Basically, if 100 people actually survive, and how many of them my model predicted. So that is the score, we are trying to find out in this.
Say it in a slightly more simpler format. Anybody else? Yeah, sure. Yeah. Hmm. 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 Okay. You're also saying something? Yeah. Go ahead.
Each someone survived,
Hmm.
it was 74% precise. Each time a model said this guy will not survive, it was 81% precise.
81% of the time correct. So if the model says I have identified a 0, 81% of the time it is correct. Similarly, 74. Anupam, you were saying something as well. Hmm. Ah. We will look at that in the confusion metric, but right now the English definition is if my model says I have identified someone who has non-survived, or I mean, if the model says all these people are non-survivals, 81% of the times your model is correct. 19% of time it will have some survivals also identified as a non-survival, right? And we'll look into the confusion matrix, and then these are your weighted average. And accuracy is nothing but your confusion matrix. So let's just look into the confusion matrix in interest of time, so that we can make good progress on the other model. So over here, now again, this is for 2 bonus points. Fastest fingers. Give me the number for recall for 1 without looking at the previous table. How did we get the recall for 1 from this table? Raise your hand if you know the answer. Recall for 1 from this table.
39 by 20 plus 39.
39 divided by 20 plus 39. Others? Any point of view? Is it correct? Recall for 0, fastest one.
83 by
83 divided by 83 plus 14. Is that correct?
Yes.
Everybody agrees? So let's just do that, right? So recall works on which axis? Actual axis. So in reality, how many non-survivals we have? 83 plus 14. So that was the same number we were looking at earlier, which is 97, if you remember, in that confusion matrix, right? So from the total non-survivals, how many of those were correctly detected by the model? 83 divided by 97 is your recall for 0, right? Which will be the same number that we're looking at in the confusion matrix earlier on. Similarly, the recall for 1 is nothing but 39 divided by this number, which is around 57 or something, or 59, right? So that is that. And what is the accuracy number here? Let this one, I will ask Ajit, because you were asking about the accuracy number. So tell me, well, how do I get the accuracy number from here? Only Ajit can answer this time. Then ask somebody in the class. Randomly ask somebody. Deepika, you want to? Tell me. 83 plus 39 divided by sum of all. So Ajit, the reason why the accuracy is defined is this way is whenever you have a correct classification. So let's just do 1, 2, 3, 4. So what is 1? Is 1 a correct classification or no? How do we know, Ajit? Yeah. So it is predicted as no. In reality also, it is a no, this quadrant. So you have to look at a 4 blocker, 2 by 2 matrix, right? So you have 4 quadrants, 1, 2, 3, 4. So I'm talking about the quadrant 1. Is that the correct prediction or no? Correct, right? Why it's correct? Because the model says no, they did not survive. In reality also, they did not survive. So this is true negative. Negative. Because I'm building a model to detect the survivals 1. Is this clear? Okay. What is the quadrant 2? Anyone? False what? False positive. So the model says they survived. So that means positive. Positive is a survival. So model says survived, but in reality they did not. So it's a false positive, right? So this is not part of the accuracy number because it's a false. Only the true things will be the part of the accuracy number, right? Let's come to the quadrant 3. What is that? False negative, because the model says no survival, but in reality they did survive. So it's a false negative. And then the last one is the true positive. So your accuracy is nothing but which are the right classification, which is nothing but 1 and 4. 83 plus 39 divided by all this number. So if you do the math, that will be around that 83 number that you are looking at, right? That's how the accuracy is defined. So this is the holy grail. All the numbers, confusion matrix numbers are coming, all the numbers like precision, recall, accuracy, everything is coming in from this 4 by 4, 2 by 2, basically 4 quadrant, right? Now, when we have, let's say, multinomial classification, right? And we'll be doing that a little bit later on. So let's say we have 1, 2, and 3. Similarly, 1, 2, and 3, right? So 0, 1, 2 predicted, 0, 1, 2 real, right? How will you define these quadrants? So the false positive, false negative notation does not apply over there directly because false positive, false negative is mostly for your binary classes, right? So let's say I'm just going to do randomly 1, 2, and 3. Who can tell me 1? What is this?
Predicted is 0 and actual also 0.
So this is the correct classification. So let's say the true 1. We will call it true 1, right? So in reality, what the model predicted versus the reality, it is correct, right? How about 2? That is also correct. So model says 1, it is 1. What about this guy, number 3 quadrant? So model says 2, but in reality they are 0. So it's a false prediction, right? So this is like, some of you will be working down the road in a data set called MNIST, which is the handwritten digits, where you're building a convolution neural network or some sort of handwriting detection model, like you can use different techniques, right? So that's where you will see 1, 2, 3, 4, 5, 6. What are the actual digits and what did the model recognize, right? So you're gonna have 9 by 9. So sorry, 10 by 10. So from 0 to number 9, 10 digits on the actual axis and 10 digits on the predicted axis, right? So their true positive, false positive, you'll get very confused. So that's why I'm saying don't get hung up on the definition of using the true positive, false positive for defining the precision and recall. Focus on this, and that's going to be much more accurate. Is this clear, folks? I'm keeping an eye on the time as well. 1 o'clock will be breaking for lunch. So if this is all good, we'll move on and then we will look into, so this is the prediction that we're doing, right? And prediction is nothing but like this one for the overall accuracy score, right? And these are the coefficients that we've gotten, right? And the coefficients are nothing but the logged out coefficient. And you get the coefficient for all of them. And remember, all of these are the scaled variables. And the equation that comes out from over here is, I think, Arpan, you were talking about that a little bit. And again, I don't get too obsessed with the equation. This is just for your information. So the equation is P divided by 1 minus P will be equal to minus 0.989 times passenger class, right? Minus 1.18 times gender, and so on and so forth. So I have asked ChatGPT from this to give me the equation. So equation is going to look like this, right? So that means higher the each of these numbers, lower the logit, right? And then we will be, if you have to convert that, you'll just take the exponential of the equations on both sides and you'll get the actual probability. But machine is going to do all of that, so you don't have to worry about that. In this one, I think most of them will be just concluding from your classification matrix only, mostly from the classification matrix, how good those numbers are, right? So moving on, this is something that you were trying to do, but we haven't discussed that earlier on. So I'll give you guys some time to understand what we're doing. So this log is the instance that we have used to fit the model. And instead of doing the predict will give you the classes. I'm saying give me the predicted probabilities or predicted probabilities for the each of the observations, right? So what does it mean? So basically you have your data in the rows, right? So for each of them, it will say the probability of 0 is 0.32 and 0.68, 0.68, right? Similarly, 0.4, 0.6, right? 0.5, 1.49 and so on and so forth, right? So it will be giving you the probabilities for each of the observations based on the variables, right? So that's what this data is all about. And I'll share this notebook so you don't have to type the code manually. So you can see what I'm doing is predict probability, and then I'm creating a data frame, and then bringing in all the other values and everything. So probability is 0, probability 1, predicted class, actual class, right? So let's just look into this one. So the probability for the class 0 for this observation, observation 29, is 86% probable this person is gonna non-survive. 14% observation or 13% observation probability that this person is gonna be surviving. Hence the probability predicted is 0, right? Let's pick another case here. Because the model is doing that only. So when you're looking at this data, no, it will do that. That's what I'm trying to show you. So over here, remember here, we did the predicted on X test. How many observations do you think this has? It is the same size as your X test, which is 156 observation. So for each of the 156 observations, it is saying 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. So it says first observation, first row, this person is a survivor. Second row, non-survival. Third row, survivor, non-survivor. So every single person has been given a the class 0, 1 class, right? And similarly, every single person will be given a probability for belonging to that class. You get that idea? Yeah. Mm-hmm. That's right. That's right. Yeah. So this, I'm just trying to do it so that you're getting the concept in your mind in terms of what is happening, right? So for every single observation, this is where the logistic regression comes in. And says and I'm just doing a random sample. So don't get worried why we are starting with the 29. I'm just doing a random sample. So for each observation, it says probability of belonging to class 0, probability of belonging to class 1. On the basis of that, I will get a predicted class, right? And then I also know the actual class. Because I know the predicted class and actual class, I get our favorite confusion matrix. Because I get the confusion matrix, we get all of these numbers. So I hope everybody is able to establish the connection how we go from like this. So all logistic regression is doing is from this equation, it is predicting the probability because it's a logit of the odds, which is probability divided by 1 minus probability, right? So from there, I got the probabilities. Then I do the logit itself is doing or logistic regression is doing. Then it will do a predicted probability. But in reality, we also know whether they are survivable or not. And because of that, I get a confusion matrix, right? So look how wrong the model is. In this case, the actual class is 1, and it is going very strongly and saying there is 86% odds that this person is going to be non-survival, right? In this case, the model is confused, right? So 51 versus 48, but because I'm using the threshold of 50%, this will be predicted as the actual as 0, right? And so on and so forth, right? Similarly, this is an extremely wrong case as well, where the actual class is survival. It was predicted as a non-survival, and the probability was very strong as well. So it wasn't really confused, right? So it was very, very high. So I hope this gives you some appreciation of how things really happen in the classification model. Yeah. Hmm? Yeah. So that's what happens. So yeah. So I think let me just talk about so that you get the reality also. Hmm? No, in reality, we don't know. Then, so okay, let me just talk about that, and we'll cover the decision tree when we are back from the break, right? So, what happens in the modeling process? So, all of this is during the modeling process, right? So, let's say I'm building the default prediction model, just like the Titanic survival, non-survival. So, who is gonna default? Who is not gonna default, right? What we call in the technical term as a default propensity modeling, DPM, default propensity modeling. All the credit companies will be doing that. So if you apply for a loan and all of that, they will make a prediction, right? So let's say there is a CIBIL score as one variable, right? Your debt to income ratio. Debt to income ratio is how much debt you have and how much income you're having, right? Your number of unsecured loans, unsecured meaning the number of credit card loans, personal loans, stuff like that. Number of secured loans you have, number of inquiries you have, number of inquiries, how many times you have inquired for getting something else, right? How long is your credit history? So when we do the financial analytics, if I do for this module, we'll be talking about all of this, right? So these are your independent variables of features, right? So now what happens is there is a training process. Training process is what we are doing right now, right? Which is, okay, I have got a certain data, I will do the split of the data and I'll confirm whether this model is working or not, right? Once I have trained, then this log object that we have trained is stored in the cloud somewhere, right? It's basically pickled, right? That's where you're gonna come in, right? Now there is a front desk sitting and collecting this information from the customer that, by the way, I mean, we need all this information from you. So fill out the form either digitally or by paper. All of this data is getting passed on to this model instance, which we have now launched in the production environment. We have already launched in the production. So all it is requiring is give me these features that you've trained the model on. So once I pass on these features, it will say there's a 77% probability of this person to be defaulter and 23% probability of this person to be a non-defaulter, right? Or it will say 0 and 1, like in terms of the classes. Now it will be for the underwriting person to take that model and then make a decision on the basis of that. 6 months down the road, 1 year down the road, when they are supposed to be paying their entire loan back, you'll get to know whether the model was right or not. You'll not get to know right away whether the model was right or not, right? And that's where basically that should feed into your training process again. So let's say you have launched the model in production and you're seeing the model is deviating. So let's say your model was supposed to be having a recall of 98%. I'm just making up a number. So fantastic looking model, right? I mean, all the defaulters were correctly identified. Now, when you actually fitted this model for the actual use cases and you collected the data for the next 1 year, you see I'm only getting a recall of 70%. So that's where you need to go back to your retraining and fitting your model on some of the sexual data which is coming in. So that's right. So yeah, yeah. But your model is also not built for all the situations. So let's say you built a model for a situation like this. Suddenly there is a world war, right? And or like suddenly there is a massive unemployment in the country for whatever reasons, right? You cannot blame the model. Hey, you told me my recall is going to be 98% because the model wasn't built for a catastrophic situations, right? So it was built for a certain macroeconomic condition. Now, if that condition has changed, then all bets are off. So that's why people are immediately coming out from the modeling and then they'll make their own decision. They will stop lending completely also because the model cannot be trusted anymore. The situation has changed completely. Then you should be imputing them. You should be either imputing them. So it's a missing value. So for example, let's say CIBIL score was not given. So it may be a hard criteria, it may be a soft criteria, right? So unless I have a CIBIL score, I will not move forward, right? So you will reject the application. Or you can say, okay, I don't have the CIBIL score, but I have all the other things which are looking promising, right? I'm gonna use a default CIBIL score of 750 for this person, and let's fly with that, right? Hmm. Yes, absolutely. Same strategy, same strategy. So if you know that your portfolio incoming prospects CIBIL score on average is 690, I'm talking about the prospects, and then they become your customer. So customer may be having an on average score of 780 CIBIL, for example. Your prospects are like, all sort of people coming in, right? So people who don't even have a great CIBIL credit history also. So if you know my prospect has the average CIBIL score of 690, and I'm missing the CIBIL score, I can plug in that number, right? You had a question, Pawan, as well, or tell me.
If people have more than 10 credit cards, they are more likely to default.
Hmm.
So then how to fit this into this model or create a new model? How to fit it?
You have to either introduce new feature in the current model, right, or build a completely different model altogether, right, and see which one gives you a better result coming out from it. If you had done a lot of feature engineering on existing variables, like say, I mean, we don't do it anymore, but the banks continue to do it. So what we call as there's a lot of process that goes in, which is, let's say I have a categorical variable, right? So they will create the buckets of those categorical variables and they will see the distribution of 0, 1, 0, 1, 0, 1. And they will say these three buckets have a similar proportion of the 0, 1s, right? So if let's pick an example, debt to income ratio. So if the debt to income ratio is 0.1, 0.2, 0.3, the default ratio doesn't change. The default probability doesn't change. So instead of having 0.1, 0.2, 0.3, I will combine these three buckets together and say this is one bucket. So there's a lot of feature engineering that you have done. So if you want to leverage that feature engineering, you'll leverage those existing variables. If you don't want to leverage that feature engineering, then you can create a brand new one. Is that fine? Shall we break for lunch? I know this is an interesting topic. We'll come back and then do the probability walkthrough one more time, and then I'll give you the reading assignment on decision tree, and then we're gonna build our first decision tree, which is very cool looking tree. And I'm just gonna show you people who are back earlier. So these are the articles you can read. And again, we are going slightly slow, but that's okay. We can pick up the speed. So you can read these articles. I think this article is not working, so I just generated something for your information. So we're gonna talk about the 35, 36, and 37. These are the links, 35, 36, and 37, right? And we'll begin with just a visual of this one first, which is the iris data. And then we'll begin the interpretation from there, yeah? Thank you, everyone.